Problem 3. Fischer and Spassky play a chess match in which the first player to win a game wins the match. After 10 successive draws, the match is declared drawn. Each game is won by Fischer with probability 0.4, is won by Spassky with probability 0.3, and is a draw with probability 0.3 independent of previous matches. A. What is the probability that Fischer wins the match? B. What is the PMF of the duration of the match? Now, writing down what we know, the probability of Fischer winning is equal to 0.4. The probability of Spassky winning or Fischer losing is 0.3, and the probability of a draw is equal to 0.3. Well, the probability for Fischer winning a game is 0.4. However, we have 10 different possibilities to think of. Fischer winning in the first round, Fischer winning in the second round, Fischer winning in the third round, and so on and so forth. Now, what's the probability of Fischer winning the first round? It's 0.4. What's the probability of him winning the second round? Well, it's the probability of him drawing the first round, which is 0.3, times the possibility of him winning the second round, which is 0.4. Third is the probability of him drawing the first round, drawing the second round, and winning the third round. So we can see a pattern here. It's the probability of him winning times the probability of him drawing to the power of some n. Now, on the second match, n is to the power of 1. On the third match, n is to the power of 2, right? Here we can say draw 2 for here. So we can actually say n minus 1 or L minus 1. So for round 1, this will be 0, right? 1 minus 1 is 0, so it will just be the probability of him winning. And we want to sum all of these up. So we're going to take a sum from L equals 1 to 10, 0.3, L minus 1 times 0.4. Well, this is the probability of a draw, and this is the probability of Fischer winning, right? And actually this will give us around such a value when calculated. Now, erasing all of this, we now want to find what is the PMF of the duration of the match, right? So we're looking to find the PMF of the duration of the match. Well, what's the probability that it lasts one round? Well, it's the probability of either Fischer or Spassky winning, which is 0.7. That's the probability of it lasting one round, right? What's the probability of it lasting 2 rounds? Well, for it to last 2 rounds, the first round will have to be a draw, and the second round will have to be won by one of them. And this goes on and on and on and on. Again, we can see a pattern developing, which will be 0.3 to the power of some x times 0.7. Now, writing this down, we get 0.3 L minus 1 times 0.7 for when L is equal to 1 9. Now, we don't write 10 here. For 10, this is a different scenario. For 10, the probability of it lasting 10 rounds is what? It's the probability of drawing 9 times. Now, we don't need to take into factor the probability of either of them drawing or winning the 10th round, because we know as soon as they reach 9 draws, it will end at the 10th round, no matter what. So here we write 0.3 to the power of 9 for L equals to 10. Now, let me ask you something. What's the probability of them going to 11 rounds? Well, 0. Because automatically, after 10 rounds of draws, the match is declared drawn, right? So the match ends after 10 no matter what. So the probability of any other thing is 0, right? Now, what does this equation here even mean? What is this telling us? This is saying that into this equation, right? Whenever you input, here is an L by the way, whenever you input a centered number, so if you enter 3, you're asking it what's the probability of this game lasting 3 rounds? And this function, or this probability, will come here and it will look 3. Okay, what's the condition for 3? It's here. It will take this formula, it will input 3 into it, which will be like this, and it will spit out the answer for this. So for each L you put in, this has to give you an answer. If you put in 11, it gives you 0. If you put in 9, it will give you like this. And that's basically the question.